All right, here I am going to solve for you the week 4 Monday pre-class warm-up worksheet questions. Hopefully you've printed those off, the PDF that was posted, and you've tried them on your own. You can kind of see that it's a mixture of some old questions followed by just, a couple of new questions. And I'm going to work you through them. So let's get started. This one's definitely a bit of a throwback. An object weighs 15.6 grams, so that is a mass measurement. And it has a volume of 5.40 cubic centimeters. The question is asking how many deciliters does 2,390 grams of the material take up? There's many different ways to solve this. I'm going to do it the way that I'm most comfortable with, the way that I kind of think about when I wrote this kind of question. And then I'll show you another way that you can do it. The first thing I'm going to do is I'm going to solve for the density. So the density is the relationship between an object's mass and its volume. So I'm going to solve for this object's density. We know that it weighs 15.6 grams, and it has a volume of 5.40 cubic centimeters. So that is a mass measurement, a volume measurement. Remember, 1 cubic centimeter is exactly equivalent to a milliliter. So I'm just going to plug in 15.6 grams divided by 5.40 cubic centimeters, and that gives me a density of this object of 15.6 divided by 5.4, 2.89. I'm going to round it to 3 significant figures because each one of my measurements is 3 significant figures, so 2.89 grams per cubic centimeter. Now remember, when we're talking about density, I like to see density as a conversion factor. What that really means is that there's 2.89 grams of the object in every 1 cubic centimeter of that object. So now I'm going to use this density as a conversion factor in this next portion. So how many deciliters does 2,390 grams take up? So we have 2,390 grams of the material. We know that the density says that there's 2.89 grams in every 1 cubic centimeter. We know that every 1 cubic centimeter is equivalent to a milliliter. There's 1,000 milliliters in a liter. And every 1 liter is 10 deciliters. Double check. Everything cancels like it should. Grams to grams, cubic centimeters to cubic centimeters, milliliters to milliliters, liters to liters. You're left with an answer of deciliters. So in order to do this, I'm going to do this on my calculator right now. 2,390 times 10, enter, divided by 2.89, enter, divided by 1,000. 8.27. And again, I'm going to round it to 3 significant figures. This number out front, 2,390, only has 3 significant figures. There's no decimal point. So that 0 that's to the right of the digits is important. It's a placeholder, but it is not significant. So there's 2,390, 3 sig figs. So my answer should also have 3 significant figures. So it is 8.27 deciliters. So that's how I would solve it. Another way that you could solve it is without actually solving for the density. You can use the 15.6 and the 5.4 as the conversion. 2,390 grams, 15.6 grams takes up 5.40 cubic centimeters, and then everything else is the same. A cubic centimeter to a milliliter, 1,000 milliliters to a liter, and every 1 liter is 10 deciliters. I'll get to the same answer. The only difference is here I did the actual division, and then over here I did the division is kind of like part of the question as I go along. Either way, the answer you should get is 8.27 deciliters. Next up, we had the protons, neutrons, and electrons charts. I'm going to need a periodic table here. I don't actually have mine out, so let me grab that real quick, just so I have my periodic table right in front of me. Here we go. Beautiful. All right. So, protons, neutrons, and electrons. The most important thing to remember, this is the mass number. All of these are the mass numbers. Mass number is the whole number. It is the sum of protons plus neutrons. So we have a copper 2 ion. That's what this is called. This is called a copper 2 ion. We're going to learn more about that in the lectures from today. So this is a copper 2 ion, and in particular, it is an ion of copper 65. So the number of protons. Go back to the periodic table. Copper is atomic number 29 on the periodic table, so that means it has 29 protons. Figuring out the number of neutrons. The mass number of 65 minus the number of protons gives you the number of neutrons. 65 minus 29 gives you number of neutrons of 36. Electrons, you got to be a little bit careful. In a neutral atom, protons and electrons are equivalent. So if this were neutral, it would have 29 electrons. It's not neutral. It has a 2 plus charge. In order to be positively charged, the atom must lose electrons. So cations are formed from loss of electrons. You lose electrons to become positive. So if we lose 2 electrons, that means we only have 27. 29 would be neutral. We lose 2 electrons to become positively charged. That means we have 27 electrons. Now we have an atom of neutral bromine 81. Bromine is element 35, so it has 35 protons. The number of neutrons is 81 minus 35. That gives us 46 neutrons. Number of electrons, this guy is neutral. It has no charge on it. Since there's no charge, protons and electrons are equal. Here we have the magnesium ion. I want you to notice it doesn't have that Roman numerals in parentheses. Again, we're going to learn about that today. But this is the magnesium ion. Magnesium will form 2 plus ions. It's in group 2. It's an alkaline earth metal. It has 2 valence electrons. Every time when it wants to gain stability to look like a noble gas, to fill its octet, it loses those 2 valence electrons, and that's why it has a 2 plus charge. So the number of protons, magnesium is atom 12 on the element 12 on the periodic table. The number of neutrons here is 13. 25 equals 12 plus 13. And the number of electrons is 10. Cations are formed from loss of electrons. Last up, we have the nitride ion. Negatively charged ions are called anions. Anions are formed from gain of electrons. And that's when it gets the ending to change to IDE. So anions will always change their ending to IDE, monatomic anions. And we know that nitrogen is going to form a -3 because nitrogen is in group 5 of the periodic table. Since it's in group 5, it has 5 valence electrons, and it will gain 3 electrons to look like its nearest noble gas, which is neon. So nitrogen will gain 3 electrons to look like neon. That forms the 3 minus anion, nitride ion. So nitrogen is atom number 7, so it has 7 protons. It also has 7 neutrons because the mass number is 14, so 7 plus 7 is 14. And the number of electrons is 10. It would have 7 if it was neutral. It gained 3, so it has 10 electrons. This, again, when you have the same number of electrons, is called isoelectronic. Fancy word just for meaning same number of electrons. So those 2 species are isoelectronic with each other. It is also isoelectronic with noble gas neon. Alrighty. Next up, we want the full and shorthand electronic configuration for the chloride ion. Be very careful. Okay, this is going to happen on an exam, I know, because I've given this kind of question on an exam many a time, and people have gotten it wrong. So be careful. Make sure you are reading. I want this for the chloride ion. We didn't do orbital filling diagrams, and so I wouldn't worry about that for right now. I might do orbital filling diagrams at some point in time. I might not. I haven't decided yet. But for right now, we're not going to worry about orbital filling. First, we're going to do the full electronic configuration for the chloride ion. So first, go to chlorine. Chlorine is a halogen. It's in group 7. It has 7 valence electrons. So think about what charge the chloride ion will have. Since it has 7 valence electrons, it will gain 1 electron. The chloride ion has a -1 charge. Neutral chlorine has 17 electrons, but the chloride ion has 18 electrons. It is isoelectronic with argon. So it has 18 electrons, not just 17. It has gained an extra electron, so it will have 18 electrons. So the full electronic configuration, 1s2, that gets us to helium, 2s2 to beryllium, 2p6 over to neon, 3s2 to magnesium, and then 3p6, because it's isoelectronic with argon. So it has the same number of electrons, therefore the same electronic configuration as argon. So remember, if you're like counting to make sure you have all 18, 2 plus 2 is 4, 4 plus 6 is 10, plus 2 is 12, plus 6 is 18 electrons. The shorthand electronic configuration for chloride, we're going to start with the nearest noble gas that comes before. We're going to start with neon. That takes into account all of these electrons. All of those electrons go in to be part of neon. And then we go 3s2, that gets us to magnesium, and then 3p6 gets us over to argon. Just in case anyone is interested about the orbital filling diagram, the orbital filling diagram would look like this. You start with neon. 3s has 1 possible orbital for it, and 2 electrons live there. The electrons go in singly first before they pair. And then 3p has 3 possible orbitals that the electrons can live in, and the electrons go in singly first before they pair. So that's what the orbital filling diagram would look like for the chloride ion. I haven't talked about it in class. If you're like, holy crap, this makes no sense, don't worry about it. I was just showing it as extra material in case anyone is interested. And then last but not least, this is what we ended class with last time. Excuse me. And this is going from name to formula for simple ionic compounds. So, name to formula is hard. All right, so I'm going to actually save those first 3 for the end. Name to formula is tough. Formula to name, that's much more straightforward. Formula to name, all you do when you go from the formula to the name, let me go with this dark purple here. Formula to name, you name the cation first, and it just gets its name. So that's calcium, and that's the cation. Metals make cations. Nonmetals make anions. Okay, so the cation comes first. Calcium is the cation. It comes first. It just gets its name. Its name is calcium. The anion comes second, and it gets its name, but the ending changes to IDE. So CaCl2 is calcium chloride. Straightforward, can't get any more simplistic than that. So the next one up, the metal comes first, the cation comes first, and it just gets its name. That's magnesium. The anion goes second, and its ending changes. So that's magnesium phosphide. That's the name for that guy. Those ones are the most straightforward. Formula to name for the simple ionic compounds. Now, let's do a little bit harder. We're going to go name to formula for the simple ionic compounds. Again, I said this in class and I'm going to say it again. The best way to do this is to take your time. Don't go too fast. Slow down. Always go back to the ions. Okay, so aluminum is a metal. Aluminum is in group 3 of the periodic table. It's down there below boron. So aluminum has 3 valence electrons. So there's the Lewis dot structure, electron dot structure for aluminum. When it wants to look like a noble gas, it loses those 3 valence electrons to become isoelectronic with neon. So aluminum has a 3 plus charge. Iodide is a halogen. It's a group 7 of the periodic table. It has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It will gain 1 electron to look like a noble gas. 1, 2, 3, 4, 5, 6, 7, and 8. So iodide has a -1 charge. Now we have to bring these together in a ratio such that overall it becomes 0. Overall, the ionic compound has a neutral charge. Aluminum has a +3, iodide has a -1. So we're going to bring them together in a ratio of 1 aluminum for 3 iodide. So the chemical formula is Al(I3). So we have 1 aluminum ion and 3 iodide ions. So overall we have that +3 from the aluminum, and overall we have a -3 from the iodides. Al(I3). Strontium is in group 2 of the periodic table. It has 2 valence electrons. When it loses its 2 valence electrons to look like a noble gas, it has a 2+ charge. Sulfide comes from sulfur. Sulfur is in group 6 of the periodic table. It has 6 valence electrons. It gains 2 to look like a noble gas. This is what I call a match made in heaven. 1 strontium to 1 sulfide, +2, -2, evens out to 0. So this is SRS, is the chemical formula for strontium sulfide. Potassium oxide. Potassium is in group 1 of the periodic table. It has 1 valence electron. When it loses its 1 valence electron to look like a noble gas, it becomes a +1. So the potassium ion will always have a +1 charge. Oxygen is in group 6 of the periodic table. Gains 2 electrons to look like a noble gas. So oxide ion has a 2- charge. Looking at this to balance out the pluses and minuses, so overall it has a 0 charge, gives you a chemical formula of K2O. 2 potassiums for every 1 oxide.